Next example problem we'll look at is problem number 80 on page 58, chapter 3, explaining motion. And the problem reads, a fully equipped astronaut weighs 1,500 newtons on the surface of the Earth. If the astronaut has a weight of 550 newtons standing on the surface of Mars, what is the acceleration due to gravity on Mars? So we're asking us to find the acceleration due to gravity on Mars. What's given is the weight on Earth. It's given, and that is 1,500 newtons. The weight on Mars is given, and it is 555. That's all it's explicitly given in the problem. We know that the acceleration due to gravity on Earth is 9.8 meters per second squared. We're going to need to know that. We're going to need that to solve this. And the equations are going to be useful, or that weight is equal to mass times acceleration due to gravity. So on Mars, the weight on Mars is equal to the mass of the astronaut times the acceleration due to gravity on Mars. And this is what we're looking for, right? We know the weight on Mars, but we don't know the object's, the astronaut's mass. So we have two unknowns here. So we've got to figure out what this mass is. Well, how do we figure out the mass? Well, we can use the other information given. We know the astronaut's weight on Earth. We know the acceleration due to gravity on Earth. We could find the object's mass from its weight, the equation for weight on Earth. So its mass is equal to the weight on Earth divided by the acceleration due to gravity on Earth, which we use E for Earth. And now we can substitute this in for mass here. So the weight on Mars is equal to the weight on Earth divided by the acceleration due to gravity on Earth times the acceleration due to gravity on Mars. Solving for acceleration due to gravity on Mars, we get the weight on Mars times the acceleration due to gravity on Earth, divided by the weight on Earth, right? If you divide by a fraction, same as multiplying by the reciprocal. That gives us 555 newtons times 9.8 meters per second squared, divided by 1,500 newtons. Grab a calculator here. So notice newtons will cancel out newtons. We're left with units of meters per second squared, which you should, because we're trying to get an acceleration due to gravity on Mars. This number is smaller than that number, so this quotient is going to be a number that's less than 1. Multiply a number that's less than 1 by 9.8, we're going to get a number that's smaller than 9.8, which makes sense because we know that Mars is smaller than Earth, so the acceleration due to gravity on Mars should be smaller than on Earth. And we know that because the weight of the astronaut on Mars is less than the weight of the astronaut on Earth. And you see that this is about a third, right? It's roughly a third. The weight of the astronaut on Mars is roughly a third of the weight of the astronaut on Earth. So this is going to be roughly a third. And so the acceleration due to gravity on Mars should be about a third of that on Earth. You know, this is just approximating. So a third of 10 is, 3.33 something. So it should be around 3 and change. So 555 divided by 1,500 gives me 0.37. So it's close to a third. A third is 0.33333. Repeating. So take that times acceleration due to gravity, 9.8. I get 3.626. I round that to 3.63. That's the acceleration due to gravity on Mars. It's less than that on Earth, and yeah, Mars is smaller than on Earth, and it's a smaller weight. Astronaut has a smaller weight, so that makes complete sense. You feel confident in that answer.